So now we're gonna be doing the next 9 through 16 problems for Tomasulo. Yeah, I don't expect anybody to watch, but if you want to, feel free. Alright, so let's start. I need to find my thing. Alright, time to spam people with links. Not really, but yeah, 9 through 16. Here goes, boys. Who else might be interested? This guy, this guy, this guy. Okay. Where's Kevin? Let me get Kevin here. You're bad. Thanks for the support. Appreciate it. Let's see. Who else is gonna join us? Alright, that's it. Let's see. Alright, time to start a Roni. Am I right? Alright, I gotta get my proms up on the side. Let me see. Went through 8 kappa. Video is in my channel, so yeah. Let's see. I was about to do something. Fine. Oh no, I closed it. Alright. Alright, we're starting, boys. I need to find the. Okay. Time to get started. Can I even like zoom this in? Alright. Here goes, boys. Number 9. Find 255 using tan 255 using sum or difference formula, right? Sum or diff. I'm just gonna write and then form. Let's see, Tomasulo 2.0 right here. Hell yeah. Zachary Chang, where's the elevator music? Elevator music is in the background. Can you hear it? I should be able to hear it, right? Alright, let me see. Time to grab some stuff out. Okay, so right here we have the tan 255, right? And let's see, how do we get this, right? So basically you want to grab from the unit circle. Hold on, let me just make a new layer to make sure I don't draw over it. Let's see, maybe like right here. I'm gonna box my camera off, just so I don't accidentally draw over it. How do I change the opacity in this thing, man? Oh, right here. Okay, I can still see it, I think. Okay, cool. Alright, nice. Okay. So tan 255, right? Let's say I have a unit circle. I kinda don't want it to be on like one of these lines, right? So 255, what I can do is I could actually use this angle right here, which is 225, I believe, right? 225 degrees, and I could use this angle over here, which is pi over 6, and this angle would be, let me check. Alright, the number, I guess, would be 30. So, you know, 225 plus 30 obviously equals 255, right, boys? So, now that we have this problem, or like this thingaroni, majiggeroni, whatever, we can now do the addition or the tan, you know, subtract or tangent sum or difference formula. Holy, it took me like 20 years to get that word out. Alright, so the formula is tan x plus tan y, since this is addition, over 1 minus tan x tan y, right? So in this situation, we got tan x. So this is ASTC, as everybody knows. ASTC, tan is positive, and you know it's gonna be rad2 over negative rad2 over rad2 and negative rad2 over rad2. So you know, just divide sine by cosine, and we get 1, which is perfectly a good number, 1. And then with the 1, I could add tan y, right? Tan y. This right here would be on the unit circle, rad3 over 2 and half. So in that case, you want to divide. This music sucks. Well, how about you make your own songs? You probably can't. Kappa xd. You want to rationalize this, so you get rad3 over 3 for your tan. So 1 plus rad3 over 3 over 1 minus, again, it's going to be rad3 over 3 because tan x times tan y. That's because there hasn't been any good music for the past 30 years. He's right, he's not wrong. 1 minus rad3 over 3, right? This is how we're going to get this. So what I'm going to do, right, this is like 4th grade stuff, I guess. You want to just put everything in common denominator. When did we learn fractions? Kind of forgot. I never really understood it. 3 rad3 over 3 over 3 minus rad3 over 3. And you know, if you have that, then you pretty much just want to divide it, right? Oh wait, sorry, there's a plus here I'm missing. Oh man, now it's so ugly. Plus, there you go, just forgot it. So we're gonna get 3 plus rad3 over 3, since we were dividing, subtract, or multiply reciprocal. 3 minus rad3, cancel. 3 plus rad3, 3 minus rad3, right? As far as I know, you don't want the bottom to be like, you know, you don't want the rad there, so you could cancel it out. So you'll get let's see, 9 minus 3. The top you're gonna get 9 plus, I'm pretty sure that's 6 rad3, right? Yeah, 6 rad3 plus 3. So I'm gonna move over here. So now we're gonna have 9 plus 6 rad3 plus 3 divided by 6. So we're gonna get 12, because you're adding this and this. 12 plus 6 rad3 over 6. This could be 2 and this could be 1, and 1 is just it by itself. So you can just have 2 plus with rad3. So that would be the answer. Let me check if I'm right. I'm probably wrong. I don't know. I'm usually wrong. Probably really bad at this kind of stuff. Where is the answer? Alright, time to find it. And stop trolling. Is it 2 plus rad3? Yes, we actually got it. Like, holy. I'm actually getting untilted, maybe? Alright, so that's it's number 9. 2 rad3. If you don't know how to do it, rewind. Always here. Holy, what did I just do? Tripping. Backspace? How do I erase this? Like, seriously? I have to do this? Alright. Number 10 time. Let's go. What's up, 4 viewers? You're probably like half asleep, right? I wouldn't be surprised if you are, because that's me every day in class. Let's see. Man, should I just get my own worksheet out? Instead of looking at a picture. That might be a better idea. Hold on. Getting my worksheet out takes time and effort. Boom. Just kidding. It's right here. Oh, shoot. Not that. Boom. Right here. Number 10. We're about to witness with our own eyes. 10, we got find cosine of arcsine and plus arctan x. Alright, boys, we're gonna have to find out how to do this kind of stuff because it's kind of hard. So you want to find cosine of that, right? So let that, or in Tomasulo's method, he's like, let this be something, let this be something, right? What I'm probably saying won't make sense, but pretty much what you gotta do is you gotta make them triangles. And since you know this is arc sine, you gotta be careful. Arc sine, arc sine. You know arc sine, if it's like sine, it goes like from here to here, positive here, negative here. Tangent is actually also from here to here. So in that case, we're gonna make the triangle negative sine right here. This is gonna be a 12/3 SOHCAHTOA, opposite over hypotenuse, opposite. Okay, so you know it's gonna be right here. I'm just gonna mark an X. Opposite negative 12 over hypotenuse 13, and little did you know 5, 12, 13 is also a perfect right triangle. So now that we have 5, you can actually find the cosine of that, and you already know like how to do the the cosine plus formula, right? Because cosine addition formula would be, what is it? Would be cosine addition. Hold on. I got this. It's in my head. All right, cos x cos y minus sine x sine y. All right, so now we have that, right? And that's just one of the triangles, and then this will be the other triangle. Holy, I'm drawing really bad lines like that. I'm just gonna call this y, even though this is that. So we're gonna call this x right here, and we're gonna call this thing y. So tangent of x, tangent is opposite over adjacent. So opposite would be, because this is gonna be that's equivalent to x over 1, right? So x and adjacent 1. So hypotenuse has to be x squared plus 1 squared, and then square root it. So you have that, and 1 squared is just 1. So you get x squared plus 1, and then in that case, then you would have to plug in this formula right here. I'm gonna make it in red, be like Tomasulo and change colors. So that formula in red. So cosine of x, right? This is the x. This is triangle x. Cosine would be adjacent over hypotenuse. So adjacent is 5, hypotenuse 13, and since you know that it's right here, it's gonna be positive. So and cosine of y, again, adjacent over hypotenuse, adjacent over hypotenuse, so that'll be, hold on, I'm just making sure I'm doing everything correct, subtracted by sine x, so sine x, right? Opposite over hypotenuse.
Stay forever.
Sorry, I just spaced out. Opposite over hypotenuse, negative 12 over 13. And then there's going to be sine y, which is opposite over hypotenuse, x over rad x squared plus 1. Alright, so now you just multiply them together. So this one you have 5 at 13. What's neat is that they're already in a common denominator. So then you'll get 5 plus 12x over 13 rad x squared plus 1. And I think that should be the answer. Yeah, it is. So in fact, that is the answer. Oops, did not mean to. Right there, 5 plus 12, that's a 12 by the way, or 12x plus 5. You can rewrite it either way. I would rationalize the bottom, but like I think this is the simplest way you could do it. So that's number 10. 6 more to go. Deleting the whole thing. Make sure you rewind if you missed anything. Right? Let me make sure the answer is correct before I erase everything and be a failure. Yeah, everything seems to be right. Okay. erasing 11. Hold on. Thank Lord I ain't in Tomasulo. Lol. 11, let's see. We got find secant of x plus y if tangent is 7/24 and cosine. Oh wait, okay. Tangent of x, hold on. And cosine of y equals to -4/5. It says right here, both x and y in quadrant 3. So, what I would do first is, let's see, make the triangles again, same thing, because you got the tangent and the cosine, and that's not a a pi over something angle. So tangent, both in quadrant 3, that's pretty much free for you already. Holy, bad triangle. Alright, so we're gonna make this, we'll just call this x, right? Because it's x anyway. So tangent of x, tangent, opposite over adjacent, like that. So then in that case, the hypotenuse, if you didn't know, would be 25, because again, perfect triangle, right triangle, I guess. And then we also have another, holy, dude, these lines are tilting me. Alright, we'll do that. Y, it's gonna be right here. Y, make a better Y. Cosine 4/5, cosine, that one is adjacent over hypotenuse. 7/24 is negative, no. Well, right here it gives me that it's positive, right? So therefore you'll change the sign afterwards, or like when you're working the problem. So yeah, I mean, you could add negatives here. I mean, it doesn't really matter. What matters is that, like, when you're trying to find like sine, for example, then it would that's where you would do it. But I guess you could also put -24 here, -7, -20. I mean, it still works, but whatever. And then you know that you're trying to basically find 1 over cosine x plus y, right? That's pretty much this and this. Oh, this and this is the same thing. Yeah, it's quadrant 3. Alright, so you already know from the original equation that will be cosine x cosine y subtracted, because that's a plus. I know, it's kind of trippy. Sine x sine y. Cosine x would be cosine x right here, right? That actually would be 24/25. Or I think this is where the negative comes in. -24/25 times. Hold on, let me make sure. Yeah, that's where the negative comes in. So times -4/5 subtracted by, because -4/5, that's the cosine, subtracted by cosine of or sine of x, so sine of x opposite over hypotenuse. Okay, so that'll be negative also. Negative. And then this one will be this adjacent one, which is 3, because 3, 4, 5 triangle. -3/5. So if you do all this together, you're gonna get 96/125, right? Subtracted by, and then this will be a positive, so 21/. 125. So the answer, you'll get 75 over 125, which, if you don't know, is pretty much what is it? 3/5. Yeah, my bad. Took me a long while to think. 3/5, but that's not the answer, because what we worked was this equation, right? We forgot to inverse it. So 1 over 3/5 is pretty much, the reciprocal. So 5/3, and that should be the correct answer. All right, next up. Alright, 4 more, boys. Find the exact value. Alright, this one's an easy one. Exact value. And then sine pi over 12 cosine So whenever you see the sine, cosine, and the cosine sine, you already know that's like a sine property, right? A sine formula, a multiple angle formula, right? I think, or sum and difference formula. My bad. And the sum and difference formula would be addition, because it's sine, cosine, cosine, sine. So that'll be a sine addition formula. So we'll get a sine addition formula, and that's the angle. So you already know sine x. Because originally it's sine x plus y. So sine x, so that's x. These two are x's, and cosine of y plus pi over 4. So in this case, we're gonna get sine pi over 12. I want to make them common denominators, so times 3. 3 pi over 12 will be sine 4 pi over 12. You could simplify that, so you get sine 1, or it's not even 1, just pi, because you don't need to write 1 there, over 3. And what is the sine of pi over 3? So pi over 3 would be this angle right here. Very, very ugly, I know. Right here. That's pi over 3, and you already know that it's going to be half rad 3 over 2. So, since cosine, you already know it's like this, cosine, that's a sine, so therefore our answer will be rad 3 over 2 using the sum and difference formula. Alright, I've been live for 22 minutes, not bad. 13 time. Whoa, what am I doing? Alright, 13. I'm gonna get the paper out. Write sine squared x and cosine squared x, and it's in terms of the first power, so you can't have that. So you basically gotta simplify the powers down. So what I could do to begin with is, we already know the formula for that, right? So if you want that, that will actually be sine squared x. So sine squared x is gonna be holy, that's one big parentheses. Alright, so that will be, let me try to think of this in my head. 1 minus cosine 2x. Okay, yeah, I just can't. I have to look down. I have to memorize all this. So 1 minus cosine 2x, and I know the cosine one. That one is easy. I'm still looking down just to make sure I don't want to get it wrong. Cosine 2x over 2. So when you have that, there's the over the line, by the way. You just gotta multiply them together. So you have 1 minus those two cancel, so you have cosine squared 2x over 4, right? Because when you're multiplying negative and positive, the middle term cancels, and you're just left with the negative whatever it is squared. So then the cosine squared x is also another term, that we have to use. So 1 minus, we'll have a big parentheses here. That's going to be 1 plus cosine. This time it's going to be 4x because we're plugging in the 2x from here. And because this one we plugged in 1x, right? So we got 2x here. If we have 2x here, then we're going to get a 4x over 2. 4. I should be doing everything correct so far. Let me check really quick. Alright, yeah, I think I'm doing everything correct. So, in this situation, I pretty much would, since there's a negative here, I'm just going to distribute it to the inside. So that'll be, or this is going to be 1 over 1, by the way. So 1 over 1 minus 1 minus cosine 4x over 2. So that'll be 2 minus 1 minus cosine 4. If we put them on all in common denominators, and over 4. Like that's a big complex fraction. So then we'll just have the simple 1 minus cosine 4x over 2 times 1/4 because I'm dividing it by 4. So I have 1 minus cosine 4x over 8. That should be the answer. I'm checking. Minus cosine 4x over 8. Yep, that is the correct answer. I'm going to box it. Leave that there for a while. Just kidding, I'm going to erase it now. That's 13. Alright, 14. 2 more. 14. This would be, find, I'm trying to read it, cosine. You have to solve for this. And what you know is sine of theta is negative 5/13. And what you also know is 3 pi over 2 bigger than theta, bigger than 2 pi. So then, you know, in the unit circle, that's 3 pi over 2 pi, or yeah. So that's 3 pi over 2, so that means the angle is bigger, right? So therefore it has to be right here. Has to be that kind of triangle. And give me 1 second. Alright. And you know that if it's that kind of triangle, then you know the sine of theta is gonna be negative 5/13, right? So sine is opposite. Hypotenuse, so katoa, so sine opposite of hypotenuse. And then this you already know is gonna be a 12, 5, 5, 13 triangle because it's a perfect right triangle. Once again, Tomasulo being nice. But we're not trying to find theta, right? We're trying to find theta over 2. So in that case, we have to basically move or divide this by 2 to know which quadrant we're in, right? So we're dividing everything by 2 here. So this is going to be 3 pi over 4 bigger than theta over 2 bigger than pi. So 3 pi over 4 as you know is actually right here, right? Somewhere here. And pi is right here. So that means it's the triangle would look something like this, like that. All right. So this is the new triangle basically, because it's bigger. It's smaller than pi, so it's going up here, but it's bigger than 3 pi over 4. So that's exactly the triangle. Then now what we want to do is basically, you already know that cosine here. So cosine is positive here and here. Cosine is negative here, right? So we gotta make sure of that. So whatever our answer is gonna be negative. And basically now you just solve it. So cosine, you use the plus or minus formula, but you already know it's negative, so it's a negative. of 1 plus cosine 2x over 2. Making sure. Okay, see, this is why this is a good thing why I made sure, because it's not 2x, it's just x over 2. Right. So now we could basically plug everything in. So negative. Holy, that's bad. 1 plus cosine of x, or cosine of theta, over 2, because we're trying to find theta over 2, right? So then that would be, hold on, let me make sure real quick. 14, just to make sure I'm not doing anything wrong. 1 plus 12 over 13 divided by 2. Want to put everything in rad form. You already know why it's 12 over 13, because it's, you know, this is theta. So what you want to do, put everything common denominator, 13 over 13 plus 12 over 13 divided by 2. And you would get, let's just skip the process, negative 25 over 26, all divided by 2. And what you could do with that is you actually can divide the, I'm skipping ahead a step. 13, same denominator. Then what you want to do is you want to divide it by 2, right? So then you'll get negative like that, basically, because you're dividing by 2. So then you have negative 25 over 26. That's why I skipped a step. Then what you want to do is it equals to pretty much, you could pretty much take out the rad, because that is pretty much equal to this, right? And basically you could take out the 5 out here. It cancels out, so negative 5 rad 26. And since you don't want to rad in the denominator, times 26, or rad 26, so you get negative 5 rad 26 over 26, and that should be the right answer. Alright, 30 minutes in, we still have time. Next question, question 15. One more, and then we're done. Find sine 2x if cosine x negative 4 over 5 and this is the same angle. Making sure that I'm cropping it right. So what you want to do is, again, make the same triangle. This time you already know that that thing is right here, right? You already know it's right there. So, and cosine is negative 4 over 5. Pi over 2 is right here, and pi is right here, so it's bigger than pi over 2 but smaller than that, so triangle right here. Cosine, negative 4 over 5, so cos sine, so katoa, adjacent over hypotenuse, so it's a 3, 4, 5 triangle. You already know that for sure. Then what you want to do is you want to make sure that there is a formula, right, for the sine 2x. So sine 2x would actually equal to, let me find it just to make sure I'm not wrong. It would equal to 2 sine x cosine x. So that would be 2 sine x would be opposite over hypotenuse, 3 over 5. Cosine x, that would be negative 4/5 right there. You already know. So that will be 2 over 1, just putting everything in fraction. I'm gonna do these ones first. So we do that, we'll get negative 24. And we're on to the last problem, finally. That took a while.
I don't love you anymore. Goodbye.
Alright. 16. Use the half angle formula. So that'll be like x over 2. Or like theta over 2, right? That's half angle. To find tangent of 112.5 degrees. So you already know what you could do here is, since this is a half angle, right? You could already make we could say theta is actually this times 2. So that'll actually be 225, right? Theta 25. So if we do the problem correctly, we're gonna end up with the tangent of x over 2. That's what we're trying to find, since x. Let's just say theta is the same thing as x, okay? Tangent of x over 2. We're trying to find the half angle, and since it's 225, so this is gonna be the formula, right? 1 minus cosine over sine x. You could also flip it. You can make it sine x over 1 plus cosine x. And then what you want to do is, you already know that in the unit circle, this angle 225, this is 180, right? And it's pi. And you add 210 right here, and 225 would literally be this one right here. So that angle would actually be, since this is 4 pi over 4, well, this will be 5 pi over 4, and we need to find the cosine of that, which that will be negative rad 2 over 2 and negative rad 2 over 2. That would be, so we're gonna have 1 minus negative rad 2 over 2 over negative rad 2 over 2. So in this case, then you're pretty much gonna have a 1 plus rad 2 over 2, because the negatives cancel right here and right here, and then over negative rad 2 over 2. So our answer will still come out negative because we're dividing a positive with a negative. So we're gonna have 2 plus rad 2, because I'm putting this common denominator. 2 plus rad 2 over 2 divided by negative rad 2 over 2. So then that would actually be that times 2 divided by negative rad 2. So it'll still be a negative, right? Because you're just pretty much multiplying it. So you're gonna have negative. So then I'm just gonna put a negative there. Then you could it all actually cancels out. So you're gonna end up having. Hold on, did I screw up anywhere? Let me make sure I didn't. I think I did somewhere. Hold on. Because I already worked these problems out. I'm just reviewing them again. So I'd have yeah, alright, let me go back there. So we'll go to that. 2 plus rad 2. I'm continuing from here. 2 plus rad 2 over 2 times the negative 2 over rad. I'm just gonna put the negative on top just so it doesn't confuse me. So we're gonna do that, and we're gonna get negative 2 because we're multiplying with a negative, and then minus rad 2. That was my mistake. Over rad 2. Yeah, I forgot that, you know, these are two different terms, so you gotta put the negative in both sides. And then you'll end up with that, and you want to times by rad 2, right? Then what you're gonna get, I'm gonna go all the way over here, by the way. You're gonna get negative 2 rad 2 plus 2, because the 2's cancel out, over 2, and then all of these 2's cancel out into 1, so that'll be negative rad 2 plus 1. Or was it minus 1? Hold on, I'm tripping again. Yeah, it's minus 1, sorry. And then that would be the same thing as negative 1 minus rad 2. And that should be the answer right here. That's pretty much today's stream, so nothing else. There's like nothing else to say. But yeah, that's 9 through 16. Hopefully you guys enjoyed it. Good luck on tomorrow's test and Friday's test. Peace out, guys.